Welcome to True Projects. In this video, we are going to explain about a project titled A New Learning Approach to Malware Classification Using Discriminative Feature Extraction. So now coming to the introduction part, the emergence of a new learning approach to malware classification through discriminative feature extraction marks a significant leap forward in cybersecurity. By embracing the power of machine learning and focusing on nuanced differentiators, this approach enhances the accuracy and adaptability of malware detection systems. As the cyber threat landscape evolves, this approach stands poised to play a pivotal role in maintaining the integrity of digital ecosystems worldwide. This approach not only bolsters the accuracy of malware classification but also reduces false positive, enabling security teams to allocate their resources more efficiently and effectively. So now coming to the objective part for this project is to use in a more accurate, adaptable and efficient era of cybersecurity. By harnessing the power of machine learning and delving into nuanced characteristics, the approach aims to create models capable of effectively classifying both known and emerging malware variants, ultimately bolstering the security posture of digital systems and networks. In contrast, the new learning approach seeks to create models that can adapt to new threats by learning from a broader range of features. This adaptability is crucial in an environment where cyber threats are constantly evolving, ensuring that the classification models remain relevant and effective over time. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. Now coming to the methodology part, first upload malware dataset. In this phase of the research, a diverse and representative dataset of malware samples is collected. This dataset serves as a foundation for training and testing various machine learning models. Second, run GIST, KNN and random forest. In this step, the GIST here stands for generic invariant feature transform features are extracted from the malware dataset. GIST captures the scene layout of an image and can also be applied to other types of data, including malware binaries. These features are then used to train and evaluate two different machine learning algorithms, that is k-nearest neighbors and random forests. Third, run dense SIFT, KNN and random forest. Dense SIFT here stands for scale invariant feature transform. Features are extracted from the malware dataset in this phase. Dense SIFT is particularly suitable for capturing local patterns and structures within an image, or in this case malware binary. Fourth, run LBP, KNN and random forest. Local binary pattern, that is LBP, features are extracted from the malware dataset in this stage. It is a texture descriptor that characterizes the local patterns in an image or signal. The KNN and random forest algorithms are again utilized to build classification models, this time using the LBP features for training and evaluation. Fifth, run multilayer dense SIFT. In this step, a multilayer approach is taken to address dense SIFT features from malware samples. This involves hierarchically capturing different levels of features, allowing for a more comprehensive representation of the data. The extracted multilayer dense SIFT features are then used to train a classification model, which could be based on a variety of machine learning algorithms. Sixth, run multilayer LBP. Similar to the previous step, a multilayer approach is adopted, but this time for extracting local binary pattern, that is LBP features from the malware samples. The hierarchical extraction of features enhances the model's ability to discern intricate patterns and structures within the data. Seventh, run extreme learning machine. Extreme learning machine, that is ELM, is a machine learning technique used to train feed-forward neural networks efficiently. In this phase, ELM is employed as a classification algorithm. It takes the extracted features from the malware samples as input and learns to classify them into different malware families. 8. Accuracy graph. The accuracy graph visually represents the performance of the various classification models. It shows how accurately each model is able to classify malware samples into their respective families. This graph provides insights into which different features, extraction methods and algorithms yield the best result and can guide the selection of the most effective approach. 9th, malware family graph. The malware family graph displays the distribution of different malware families within the database. It illustrates the proportions of different types of malware and their classes. This graph helps the researchers and analysts understand the composition of the dataset and potentially identify any class imbalance issues. 10th, predict malware from new file. This final step involves taking a new unseen malware file and subjecting it into the trained classification model that demonstrated the highest accuracy. By extracting relevant features from the new file and passing them through the model, it becomes possible to predict the malware family to which the new file likely belongs. This real-world application demonstrates the practical usability of the developed classification approach. So now coming to the execution part. To execute the project, first we need to open the code folder. Here we have a folder which is named as dataset. In this we are containing a .txt file over here. Another folder which is named as this. And in all these are all the Python files which are containing the Python scripts in it. Another folder named as model. In this we are again containing a .txt file with the extension that is .npy. Another folder which is named as test images. In this we are containing some images over here for testing. This is the main Python file which is containing the Python script in it, and here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. So now click on upload malware dataset button to upload the dataset over here. I am selecting this dataset and now click on open button to load the dataset. So here on this screen you can see that extracted 350 malware images, and each image contains 1024 features or pixels. And now click on run GIST KNN and random forest button to extract GIST features from all 350 images and then apply KNN and random forest algorithm. So here we can see GIST, KNN and random forest accuracy, and then we can see accuracy of 3 different malware family. And in graph and confusion matrix we can see how many records classified in each malware family. For example, in 24 records, classifier as dialer C malware. So now we have to click on run test SIFT KNN and random forest to extract SIFT features and apply KNN, random forest and KNN. So now here we can see SIFT KNN and random forest accuracy, and now click on run LPP KNN and random forest button to extract LPP features and apply both algorithms. So now here we can see LBK KNN got 88 and random forest got 92% accuracy, and now click on run multi-layer LBP button over here to apply multi-layer technique and then apply both algorithms to get the result. So here on this screen we can see that LBP KNN got here 78% accuracy and random forest got 100% accuracy, and now we have to click on accuracy graph button to get the graph. So now here by clicking on the malware family graph, I have got this graph, and here x-axis represents malware name and y-axis represents count of each malware family over here. And now by closing this graph and this also, now click on predict malware from new file button to upload any malware file, and then application will predict or classify malware name from that file. Suppose I am selecting this first .npy file over here. Now click on open button to load it. So here on this screen we can see uploaded file converted to binary gray image, and then application predict malware contains in that file, and this prediction result printed on an image in white color text, and now test with another image. So now closing this image. Now here I am selecting suppose this image 10, and now click on open button. So here on this screen you can see that uploaded file contains one alapple.a malware, and this prediction result printed on an image in white color text. Similarly, you can upload and test with other images also. Now closing this image. So now coming back to the conclusion part. In a world where the frequency and sophisticated of cyber attacks continue to escalate, the new learning approach presents a proactive and effective defense mechanism. By embracing the capabilities of machine learning and discriminative feature extraction, this approach demonstrates its potential to stay ahead of cyber threats, offering a promising path toward a safer digital environment. As the landscape continues to evolve, this approach stands poised to play a pivotal role in safeguarding systems data and information from the ever-present threat of malware. The precision gained from analyzing discriminative features not only improves the reliability of malware classification, but also allows organizations to allocate their resources more strategically. This leads to optimized response times and a more efficient mitigation of real threats, ultimately strengthening the overall cybersecurity posture.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.